Hi, everyone. For 1.12, where we're looking at confirming continuity over an interval, it's really just saying that in order for a function to be continuous in an interval, it has to be continuous at every point in that interval. So that means that the function can't exist, it can't be continuous in an interval if it's not continuous in an interval, right? Because you're saying that it has to be continuous at every point. So this section is really intuitive. It's just a matter of saying, listen, because it's continuous everywhere, it's continuous everywhere, really, right? So if it's continuous everywhere on the interval, then every single point, the function is continuous at that point. So when looking at these functions over here, polynomial, rational, power, exponential, logarithmic, and trig, we can say that these functions are really just all continuous in their domain. Now, I'm not saying they're continuous everywhere in X in the reals. I'm saying they're continuous everywhere in their own specific domains. So something like a polynomial, it could be something like this. I could have x squared plus 2x plus 3. Now, this is a polynomial function, and we know that this polynomial function will be continuous everywhere. It's a quadratic, and it's going to be continuous everywhere in its domain. So then we're just saying, listen, x is an element of all real numbers for something like this, right? And we know how to tell domains of these different functions. So what we're saying is that these functions over here are all naturally continuous in their domain. So something like a rational could be something like this.
I found this on the web.
Could be something like this. We're just dividing. Sorry about that. That was my Siri saying hi to me. It could be something like this, x minus 1. So then we're just saying, there you go, that's a rational. Now we know that this rational function doesn't exist at x is equal to -1, x is equal to 1, right? Because if it did, it would make it undefined. So we know that its domain doesn't even include 1, but it is continuous everywhere else. Okay? All right. Now let's look at a power function. Now a power function could be anything just like this, x to the power of 2. Anything that is raised to a power, right? So it could be b to the power of 3, right? So just anything that is raised to a power. Now, over here, we're looking at a power function, and we know that power functions will also be continuous all over their domain. Exponential could be the e to the x. And then when we're looking at logarithmic, we can say ln to the x, ln of x. And we know that ln of x doesn't exist at 0, right? Because we know that ln functions or log functions will look something like this, right? So then we're saying, okay, well, it is going to be approaching, my Siri just keeps saying hi to me. So it's just going to be approaching, it's going to be approaching 0, but it's never going to be equal to 0. And it's never going to be negative. So we know that with logarithmic functions, we already know that their domain is going to be anything greater than 0, and it will be continuous all along everywhere greater than 0. Now, with sine functions, we have something like sine x or cosine x or tan x, and I just wrote the primary functions. But we could also be looking, I was going to write trig, but we could also be looking at, reciprocal functions as well. But what you need to keep in mind is that some trig functions as well, just like ln, have vertical asymptotes. So something like, tan x, we can also see with its vertical asymptotes, it won't exist at those points, but it will exist and be continuous at every other point other than its vertical asymptotes. So then we just need to keep in mind that all these functions are naturally continuous on their domain and not just on all the reals, but on their domain. Okay? All right, everyone. So this was a really quick section. I hope that was a good, I hope that you were able to review well from this, and I hope I'll see you in the next videos where we're going to do some questions. Bye.